This is kind of an update on a previous video I've done concerning using remote I/O for the model train project and MODBUS communication. This panel here I built a little while back, which includes a 32 relay WaveShare MODBUS relay board and a 32 input module also operating on MODBUS. So what this here will do is basically it will handle all the block detection because I have the same Omron isolation solid state relay block which protects the inputs in the event of a derailment. It also uses these little boards to the RSC lights from the remote switches. You know, when they glow green or red, it sends back, this translates it to a 24 volt signal and sends it back as an input so that the PLC will know what position the switch is reading, or if the switch point's not latched, the light is out and there'd be no input, and the PLC would know that the switch is not in position. This also handles the photo eye sensors and buffered through these solid state opto isolators. So this basically would handle all the block detection, photo eyes, the remote switches, and even all the signals. I have the signals connections here, track power and the reduced track power from manual here. This is all the MODBUS and the 24 volt supply here, and then the 4 remote switches would go out here, and this includes also the accessory power and the common. These are all the track power, manual, automatic outputs, the photo eyes, and the block detection. But after building it, I started thinking about it, and it would require, of course, mounting this probably on the wall of the living room, and I'm like, I think there'd be a better solution than this, because it really wouldn't improve anything other than, you know, I could get rid of the expansion modules on the PLC, which I already have. So thinking around, I came up with a different idea. This here is a schematic of the cable layout currently with the model train project. The thing is, you have the PLC controls which provide the automatic control of the remote switches and the track power, but that has to be routed. I forgot about the touch screen. Hang on. I forgot my laptop's a touch screen. So anyway, they have to come into the engineer control panel and then be routed out to the 4 areas on the layout. So right now, as it stands, there's 15 cables that get routed to the engineer control panel, as I'll show this picture. And this here right now shows the cabling of the engineer control panel, which ends up being a lot of weight. And although that other, idea with the WaveShare and that was nice, it really wouldn't change anything. I mean, it'd be nice to be able to reduce the number of cabling, not only to the engineer control panel, but up to the layout. This right now is just simply a picture of the PLC controls, and you can see the amount of cabling that goes between the PLC controls, the engineer control panel right here, and then these go all up to the layout. And the reason why the automatic control has to be routed through the engineer control panel is because these are the relays that could control whether it's automatic or manual of these here do the track power, these here do the remote switches. These handle the direction, whistle, and bell of the CW80, so that's not part of it. That determines whether these switches, which are the track power, and these remote switches are in control in manual, or the PLC has control. And the reason why it was originally designed this way is simply put, I didn't have enough room on the PLC controls. But then once I decided to make this my around-the-wall layout, then I didn't realize how much of an issue it would become, having that much cabling. I mean, for now it's working, but it is cumbersome when I do have to take, set up the engineer control panel, because it's on a folded up table to run the layout manually. As you can see here, this is the main PLC controls, and there's of course a lot of wiring, but like I said, as you can see, there really wasn't any room to add the automatic relays and route them directly out to the layout, which would have saved on some cabling. So since MODBUS is remote and you can have a considerable distance between modules, I thought around and looked around for some other options, and I came up with this. What I was able to find online was these combination modules. This one, and this one have 8 digital inputs and 8 relay outputs, which are also high current relays, single pole, double throw. And these are just 4-bit versions of them. 4 inputs, 4 relay outputs. The idea here is these modules can actually be located up on the layout, which would considerably reduce the amount of wiring that would be needed in order to interface between the layout, the PLC controls, and the engineer control panel. Because these could handle, like, say for example, like right now, what these are designated, there's 5 of them. This first one here is going to take the place of the remote switch control and the reading of the RSC lights. This one would be on the PLC controls. Then the next one here, this would be located on the west side. This would actually handle the first 4 signals, the 2 track powers for the throughway west and side track, and the inputs would be for the block detection and the photo eyes. And the smaller one would because this would be for the south side. I mean, being that it's only single track, this would handle the 3 aspect signal with the 2 relays, the track power, and then this one just wouldn't be used. And then the inputs, which there are 3 block detects on that main line, so there'd be 3 of these would be in use. This would be the east side, which would basically do the same thing except for the east side and the teen track. And this would be for the north side, which would handle the crossing flasher, the track power, and the crossing flasher, and of course the block detection. This here would be a representation of how things would change if I use these remote modules up on the layout. As if you notice now, the amount of cabling between the engineer control panel and the PLC controls would be reduced to 7 cables, basically cutting it in half. And there would now only be a total of 7 cables going up onto the layout. This one here being the MODBUS serial cable would daisy chain from one module to the next. So that would just be common. And then you have of course the existing remote switch control would be these 4 cables. They would basically just stay the same. But then now, one cable would come up as a 7-wire cable, which would go to the west side and to the south side, because this would have not only the track power and the reduced track power, but it would also have the manual control, whether it be track power 1, 2, 3, when the layout's being operated manually. These would be tied into the normally closed contacts of the relay, so when the unit's not in automatic mode, the switches on the panel would handle it. So this would greatly reduce the amount of wiring or cabling, not only between the engineer control panel but up to the layout. And this here shows the MODBUS slave map of the 5 modules. Of course, the first one being located, slave 10 being located on the PLC controls that handles the remote switch control and the RSC lights. And then basically most of these would just daisy chain from one to the other, which is what allows the reduction of the cabling needed. So basically the cabling up here would be removed and replaced. Leave the terminal block in place, because this is what actually goes out to the various components on the layout. So the idea would be is it could mount the remote slave module here and then just simply tie it into the top part of the terminal block, leaving everything here alone and then you would just have basically far less cabling going back down to the PLC controls. Now, as far as the engineer control panel, basically what this means is, except for this direction relay, these 4 high current relays and these 4 force guided relays would just be eliminated off of this panel. They would just be gone. They'll be moved to the PLC controls, which actually, since I got the nice touchscreen. So what that would also mean is this isolation block, this Omron block, would be eliminated, because up on the layout, to provide isolation, I would simply use these Panasonic opto-isolator modules. These would be like, I would need 2 of them on the west and the east side and just 1 of these on the north and the south side. This would again provide the isolation between the track, block detects, and the inputs to the slave modules in the event of a derailment, so that you don't have track power feed back into it, because these are individually replaceable, and they even give you a little puller. Then you can use the puller to pull a module out and replace it, so that works pretty neat. And I have a lot of these in my possession, because these were of course taken from scrapped CD and DVD equipment, so I got plenty of these, so I might as well use them. So not only would that eliminate that, but since the remote modules would handle the switch control and the track power, basically all of these relays would be eliminated, because this is all the track power, this is the remote switch control, and then you have the signals. There's one in here that provides a syncing output for the tower light for manual and automatic. I basically have to flip the signal from sourcing to syncing for the pad light, tower light. So, and then this would stay, because then this origin module would still be needed to convert the 4.5 volt signal from the RSC lights to 24 volts to be as the input for the input. So basically the one module is shown here. Say I would take one of these modules, and that would be placed here, and that would replace this Omron block. And then in place of these relays, these 4 high current relays and these force guided relays would simply now go here. So the automatic manual control of track power and the remote switches would now be moved to the PLC controls, and that's why I can eliminate several cables that go between this and the engineer control panel. I moved my copy of RS Logix to the laptop originally, because since I was basically done with the development on the Windows computer up here, which was, I do have a little bit of a test layout, for testing, and actually use it more just for testing locomotives after I clean them and service them, but who knows what that'll turn into. Anyway, so I was originally figuring I was going to have to, if I had to make changes to the program, I'd have to sit there in the chair, plug into the PLC controls Ethernet switch, and make changes. But now that it's integrated into the home network, I could basically do it wirelessly from anywhere. So, but that gives just some extra flexibility. But anyway, I have a test program here running, which, as you can see, each module flashes indicating that's being accessed in red. And using some control bits to avoid overloading the buffer of the MODBUS message commands. This way one will execute before it lets another one execute by using control bits. So once this first one gets done, which reads the slave 10's digital inputs, once that one's done, then it allows the next one to execute, which this reads the status of the relays, whether they're energized or de-energized. And one thing that, if there's basically there's another set of data that would be used as the output. So instead of writing to an output on the discrete I/O of the PLC, it would write to binary bits, and then it would see that it's changed from what it read. So basically saying, okay, I want to energize relay 2 on this slave, and you put a 1 in there. Well, it's currently reading a 0, so it says, okay, we have a difference in what the relays are reading. So then it just sets a flag, and it allows this message command to execute, which actually writes out to the relays. So basically this, as long as there's no change in request, like say a signal isn't changing, or we're not going to energize it, like the track power relay is no change from the last scan, then this one is basically skipped. So by doing that, it basically allows this to do a loop around, reading all the slaves as fast as possible. As you can see, as each control bits get executed, and some get skipped, because right now I'm not writing anything to energize the relays, it skips over them, and it allows this to read as fast as possible. But I also did write a little test program on the HMI. So if I do that, see the first relay on slave 10 executes. Then I could turn it off. And then, like I said, I could also, using this jumper wire, touch it to turn on this input, and it shows as an input on there. Also, I can individually turn off, like say if there's a problem with one of the modules, I can simply turn that slave off, like say for example the last one, and you'll see this light no longer flashes because it's no longer being accessed. And this will also keep counts of errors in that, and I could also just outright stop reading the MODBUS slaves altogether. That's how you do the control. So this way it runs as efficiently as possible, because you have to remember this is serial 9600 baud, so I want to try to read, like say things like the block to text and the photo eyes as quickly as possible. Being that it's a model train layout, I don't have to have it going super fast, like a real industrial machine that operates hundreds of parts a minute. But I want to be able to read it as quickly as possible and as efficiently as possible. So using these control bits to basically let one message command read right to the slaves occur before it lets the next one execute, because you can just there's only so many that you can put in the buffer before it ends up having to wait and wait and wait, and then it slows everything up. Now this just shows that the binary bits that are being, let me try a little zoom instead, that the slaves access, as you can see, the first one would be, say, the first slave's digital inputs, and then these 8 bits would handle, these are what would be read from the relays as far as their current status, is whether they're energized or not. So say if you want to make a change, like for example, if I want to change this one, once you toggle it, you'll hear the relay click, and then now it's reflected back that, okay, this relay is now energized. And the only time it will actually perform the write is if there's a difference between this row and this row. So as long as these 2 rows are the same, the write execution is, or the write is not executed. And then I, boom, can turn it off. And I could just do like any, as you can see, turned on that output, toggle it, and it turns off. So this provides like the most efficient way to read and write to these slaves, considering there's 5 of them. Now the question is, when will this get done? Who knows? It's still just a theory. It's just something I'm thinking about. There's always things with the train project. Working on a couple other things, improving like the park routine, and who knows, I might come up with some more train operations. It's basically a never-ending project, but it's fun. So in the meantime, take care.